one-to-one functions. First off, let's start by reviewing what a function is. Remember that the definition of a function says that a function is a relation in which each element of the domain corresponds to exactly one element in the range. Okay. When we talk about the domain, we're only talking about the meaningful inputs, or the X numbers. And when we talk about the range, we're talking about the meaningful outputs, or the Y numbers that you can use in the function. So each X goes with exactly one Y. That's what makes it a function. Now, in order to be a one-to-one function, each element of the range corresponds to exactly one element in the domain. So this is kind of backwards. You still have the qualification that it's a function, but a one-to-one function is special because not only does each X go to one Y, each Y has only one X. So another way to put that is, if you have two equal Y values, then you know the X values that gave you those Y values have to be equal. So let's see if these are one-to-one functions. My first function is the function f of x, and it contains the ordered pairs 3, 5, -3, 6, and 9, 5. So what we want to look at here is each of our y's. Here I have a y of 5, I have a y of 6, and I have another y of 5. Since these y values are equal, I have to look at the x values that go with them. Here I have an x of 9, and here I have an x of 3. So because these two x values are different, we say that this function is not one-to-one. Sometimes you'll read in textbooks that one-to-one, another way to say that is invertible. This is not one-to-one. Now let me just kind of sketch this graph. The point 3, 5, 1, 2, 3, 1, 2, 3, 4, 5 would go here. The point -3, +6 would go here. And then the point 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 would go here. These points are the ones that kept this function from being one-to-one. And if you look on the graph, these functions lie horizontal to each other. Okay, so keep that in mind when we go to our next slide. Let's look at this function, f of x. Point 3, -10, 0, 6, and -0.1 pi. We want to look at each y value. Now, because each of my y values are different, I don't have any y's that would go to different x's. They each are individual y values. So this function is one-to-one. Let's look at this function f right here. I have the point 2, 1, 4, 6, 5, 1, and 6, 7. So here I see 2 points that have a y value of 1. When I look at my x's here, they are different x's. So we would say this function is not one-to-one. However, if we look at this function, g of x, each of my y values is different. So that means this function is one-to-one. And what I just mentioned about the horizontal line leads us to what we call a horizontal line test. Remember that to determine if a graph is a function, we use a vertical line test. But to determine if a function is one-to-one, we use a horizontal line test. So here we want to see if there's any horizontal line that I can draw on my graph that touches my graph more than once. If a horizontal line touches the graph more than once, then it is not one-to-one. If it only touches it once, it is one-to-one. This function fails to be one-to-one because this horizontal line actually touches the graph 3 times. So this is not one-to-one. But any horizontal line I draw on this graph is only going to touch it one time. So this graph is one-to-one.